Awesome. Hey, everyone. Great to see so many people here, actually. Very exciting. It's the first Validator call we do, right? The first big one.
The first big one.
Nice. So yeah, thank you all guys for being here. The guys, that's Max, for who hasn't met him in person yet. I'm Fabian. Troy, I see up there in my meeting. Christopher's also here. Oscar is here. Paul is here. I think that's kind of like everyone from the team that you have maybe interacted with. And yeah, maybe, I don't know, Max, if you want to take it over from now. We're both, if you guys have any questions, just feel free, like ask them on the spot. We prepared a quick agenda just so it's a little bit organized, and then after we just, I don't know, answer any questions or talk about whatever is up top of your mind, guys. So Max,
yeah, thank you very much for the intro, Fabian. I'm gonna quickly share my screen. I have the agenda here. So I'll give it a second. Okay, perfect. Structure is quite simple. So first of all, we'll give a quick intro about the overall structure again, just that everybody's on the same page, and summarize the last 6 months of what happened so fast. And then we'll jump directly in with KSYNC, which is one tool which builds on top of KYVE and the ELT pipeline. And after that, we will have a lot of time for discussions. Yep. So just to summarize, so what's the focus within the last years? What did we build? Like most of the stuff focused on the chain layer, which is like responsible for implementing the protocol. So this is where you are mostly based at. Like most of you guys like run on the plain Cosmos node, which is like the foundation, or like it's the foundation of our entire framework. And this manages like the protocol for extracting the data and likely the algorithm to validate the data. And on top of this chain, like we have the protocol nodes, which then interact with the chain layer to actually like extract data from data sources, validate it, and upload it to Arweave. If we look into like a specific pool, it basically is always like the same structure. We have one external data source, which is like in our current case, mostly blockchains. We started with the Cosmos Hub blockchain. Inside the storage pool, we have like the validators, which use a robin mechanism to select an uploader each time. Uploader bundles some of the data, uploads it to Arweave, and the other validators verify the data. And once everybody is verified, then the bundle is finalized and they proceed with the next bundle. This is then stored on Web3 storage provider. Currently, we mainly use Arweave for that. This is just a very rough overview of how the protocol works. And this is what we have worked on for the last couple, or for like the last 1 to 2 years. And then comes the next step, which is actually like the data consumers, which we have been focusing now within the last couple of months, which is then actually like extracting the data from Arweave again and making use of that data. Just a quick recap of the last 6 months. So everybody remembers the mainnet launch on March. Then like the mainnet launch was like a stage. We had like multiple phases where we like rolled out everything to make sure everything works correctly. In the meantime, parallel, we had our K on testnet, where we very quickly launched with the first pool. And then on June, this pool finally made it on to mainnet, which was the Cosmos Hub pool, supporting the tool KSYNC. So on Cosmos Hub, we store the raw blocks from the Cosmos blockchain through the KYVE mechanism on Arweave. And with KSYNC, one can make use of these blocks to, for example, sync a node. More about that later on. Then in the mid of August, we had the second pool, Osmosis pool, with an additional feature. There we did not only archive the raw blocks, but only the block results, which then enables the full usage of the ELT pipeline, which, for example, allows creating all different kinds of events running. And then with this pipeline, people can load in various data warehouses where they can then run all different kinds of aggregations to analyze the data. And then actually on the 6th of September, which is today, we launched the Archway pool, which was like 2 hours ago. So these are the 3 pools which are currently deployed on mainnet right now. So the Cosmos Hub pool has already fully caught up. So progress will probably never be 100%, like, because there will always be like, I mean, one block every 6 seconds, we have 2 minutes of like bundle times, but like we consider this like fully archived from our end, so it's up to live data. This consists of like almost, well, we have of 11 million blocks and a size of like 350 gigabytes. And this only contained the raw blocks, and then we can use KSYNC to like, sync a new node from that. Then with osmosis node, we are currently at 12%, and I've only archived 1.4 million so far, 15 gigabytes. But we expect this also to become way bigger because like with the block results, this should usually like lead to more data, especially like with osmosis, they also start with like a little pool and then become more and more pools. So we expect definitely this number should be bigger than this, definitely in the end. And of course, Archway, there's not that much progress yet, of course. One main thing that might also be interesting, like a lot of you guys are running a chain node or like a Cosmos node. And now just for you to quickly recap what it means to run like a protocol node, like for a protocol node, you usually need to run 2 types of node, which is the source node, which is like the data source we're archiving. So for now, it would be a Cosmos node, osmosis node, or like the Archway node. And I think you're experts in running Cosmos full node. Basically, we only need like the blocks because the blocks store DB only also contains like the block results. Of course, you need to make sure that you always upgrade to the latest version. It needs to start from Genesis, and then it thinks through the entire history again. Usually, like if you have like, I would say like a medium-sized server, it's totally fine to run this kind of node. And the protocol node itself is actually like quite lightweight because it like only requires a good internet connection. It doesn't need to be exposed to the public or anything. It can stay within the private network and only access like the source node and needs internet connection to the API endpoint. If you would host the KYVE node yourself to interact with the API, then actually everything could stay within a local network. Oh, except Arweave, sorry. Still need a connection to Arweave, but then everything could be kind of local network. And the protocol node, of course, needs to make sure to have like full uptime. If your source node, for example, would go offline, then the protocol node would, for example, skip the uploader role or vote abstain. So it's not that much of an issue for now. But yes, these are these 2 kinds of nodes, because so if you're like already running a source node for other networks, could be quite easy to actually join the protocol layer. And that's so far. Then I will, so this was like the quick intro. Now I will forward to Troy, who's like the lead protocol designer, and he will like explain the KSYNC tool and how it works and give you a quick demo on how you can actually work with it to like actually make use of the archived data.
Maybe quickly pausing here shortly from my side. I saw there was one question already in the chat. I would have asked if there would be any other questions. The question was, have people got the protocol node working without running the full archival node? Yes. I think Max can also give more information, but we have a tool out there. It's called Supervisor that basically allows you to have a full archival node running, but it limits the archival node within a certain block range, and that is also limits like the storage requirements and makes it cheaper to run it. And the CrossNest guys and also the IBS guys I think have been very active on this, although I don't know if you guys from IBS are running a full archival node that you already, like using a full archival node you guys already running, or if you are using the supervisor for this. But the CrossNest guys definitely are.
Yeah, actually you almost said everything, Fabian. Like supervisor is the tool to go for like having a tool which like does not, I think it's about storage consumption, I assume.
Yeah, maybe one thing to add is that once the pool has caught up to live data, you can actually start pooling the node since you don't need all the historical blocks anymore. This is the case with Cosmos Hub right now, as previously mentioned. So we can start pooling it actually. One thing you have to keep in mind is that you should take a large block window to keep around, since if you pool too fast, you can lose the blocks which are needed for the pool. But in summary, you don't need an archival node anymore if the pool is actually live. And
feel free to try out the supervisor again. I think it should be
And I think it is actually very stable at this point. And yeah, feel free to always reach out if you have questions, of course, to that.
All right, I think then we can continue with the next slide.
Oh, I'm sorry. I thought you wanted to share your screen, but I can still keep the presentation up until you want to start a demo.
Yep, that's
Easier.
fine. Thanks. So now we get to KSYNC. That's one of our tools we use for KYVE, and basically, some of you have already used it. Some of you maybe have not heard about it. And I think since you all are validators, I think this is something interesting for you. So the goal of this tool basically is to sync archival nodes from Genesis. And because we tried that in the beginning, we encountered a few problems there with the current setup. So if you try, for example, to sync with the normal block sync from Genesis, you often have a hard time finding actual peers which have all the blocks. This is no coincidence because nodes in Tendermint often have no incentive of keeping all blocks. So often archival nodes are managed by projects themselves. So yeah, we have a hard time finding peers there. And if you actually find peers, there we come to the next problem, is that the connections are often quite bad. So once you connect to a peer, it might happen that the connection gets dropped again, and then you have to wait for the blocks to sync again. So often block syncing can take way longer than usual. And with that, we came up with a solution. We leveraged the KYVE protocol, and all the blocks we stored permanently on Arweave to make block syncing way easier. And for that, we can move on to the next slide where a small architecture diagram is shown. Thanks. And in this example, it shows how, for example, you can sync osmosis from Genesis. So first of all the blocks are archived on Arweave or any other storage provider in the future, but Arweave has some nice properties like data permanence. So that the osmosis pool stores those blocks. The pool is, for example, live on mainnet and is responsible for storing blocks and blocks results, but KSYNC is only, in this case, interested in the blocks. So once it's stored permanently on Arweave, you can pull them down with KSYNC. So it will go through every finalized block, download them from Arweave, and then apply them against your syncing osmosis node. So basically, KSYNC will act as a peer, which contains all the blocks. And the nice thing with that is that it's way more stable. It's way faster since the data retrieval part is quite fast here. So actually writing the blocks to the database is the bottleneck here. So it's actually as fast as possible. So you're usually way faster than if you would sync it through the peer-to-peer network. And to show you just how easy it is, we prepared a little demo where you can start syncing the osmosis node in just under a minute. And for that, I will just share my screen, and then I can walk you through that. All right. Can you see my screen?
Yes.
There now. Yes.
Perfect.
There is
So,
a question about the instance of what kind of instance is KSYNC?
what kind of instance?
Yep.
KSYNC is basically in the raw form just a script you can execute. And I think after I run this demo, it's clear what it does. And it's not a heavyweight node or something like that. It basically, yeah, it's a script. I think there was another question.
Yes, the question was, can you KSync up to the current height of the osmosis pool?
Yes. And I think it will be clearer after I start. So in this case, I just installed Osmosis binary with the version they used for Genesis. And for next step, I will just init this node as you would also know it. So, and then download Genesis file. That's the only thing you need to set up there. And once that's downloaded, have a little slow internet right now.
The German Wi-Fi.
That's everything you need to set up for your osmosis node. So in the next step, you can continue with KSYNC. And this is basically a script written in Go, so you can just install it like that. And you can also verify that it's properly installed. And with that, you can already start. So I just prepared every command here. But basically, what we tell KSYNC here is, okay, where's my binary? Where is my home directory for the osmosis configs? From which pool am I retrieving the blocks, and from which network? So in this case, it's mainnet. And once we start that, it will start the osmos binary, and in the background, we'll download all the KWIVE bundles, which you can see here. And the first blocks always takes the longest since the database gets initialized, and now we can see the blocks rolling in. And with this setup, you can just continue to the current pool height, and when there's an upgrade in between, KSYNC will properly exit, and then you can just replace the binary you just used with the next upgrade binary, and then you can continue with that. There are even ways to do that automatically. If you start a binary with Cosmweiser, they are provided in docs, but for now I will just leave it as is. And if I just exit this here and start the Osmo binary, normally we can see, I think, in the status that we have synced almost 1,000 blocks. So if we want to continue normally from there, we can just add some peers, and then we can continue from there on. And this was the little demo. This is, of course, also available with Cosmos Hub right now, and now Archway soon. And since the feedback of that was actually quite nice until now, we took this a step further, actually. And this was actually an original idea of KSYNC. They had the idea of if it was possible to store state sync snapshots with KYVE, and to also apply and to retrieve and apply them. And currently, we got a running proof of concept. So it will be probably possible in the future. And I think this will be helpful, especially for you validators, for the following reasons: that you can then pull down archival snapshots or current live snapshots. For example, if you are running an upgrade and the upgrade fails for whatever reason, you can just sync a snapshot at the latest height, and then you can basically use it as a backup. Or for example, for any text reasons, you have to check out the state of a chain 1 million blocks in the past, and it would take you a whole archival node to get to that height. You can just use, for example, archived snapshots, pull the latest one down, and then use, for example, the block sync to get you to desired block, and then you basically have a very easy time checking out historical states of a chain. And that's something we're actively working on, and I think we can give you some updates once we move on to our official testnet KON. But yeah, that's something exciting we will come up with. Are there any questions regarding KSYNC or maybe even the state sync development process?
Not sure if you saw, there's one in the chat.
So the binary needs to be running, but so the binary runs without Tendermint. What this means is basically that only the application on top of it is running. And KSYNC will take care of applying the blocks to that and writing its part directly to the DB. And the binary will take care to write to the application.db folder, since that's the application side. It should work with both. Go level DB, I think, is the default one, but DB backend is handled by the binary, and so that should also work. Oh, and
Awesome.
okay.
And maybe Troy, you could also maybe quickly highlight something on the state sync. Do we already have, as you said, it's a prototype we are developing internally. Do you already have any timeline on this, when we can expect to see this hitting testnet?
So since it's actually running on Korea right now, a first pool, and we had already implemented our first proof of concept state sync CLI, and we were successfully able to pull down those snapshots and apply them. I think for testnet, we will have it running in a few weeks. So very close, I would say. And from there on, the way to mainnet, of course, is then not far away. And from there on, you can, of course, use that in production.
Awesome. I think if there are no other questions, we can move on from our side.
Yep.
Yeah, all right.
Next one is Christopher. Do you want to share your screen?
Exactly.
Perfect.
So yeah, hey, my name is Christopher. Also a software developer here at KYVE, and I'm very happy to present you the ELT pipeline. And the ELT pipeline is our second product, and or second tool, and it's built with Airbyte and is the connector between the KYVE storage pools and the data destination of your choice, for example, Postgres, Snowflake, or MySQL. And therefore it extracts, the E stands for the extract part, and Airbyte, or the ELT pipeline, extracts the data through the KYVE pool from our storage provider. Many times it's KYVE, and then it loads the extracted data into the destination of your choice, and it's a very handy and low-code solution. And I just want to present you how you can set it up. Yeah.
There's a question if the quality, for whatever reason, of your screen share is actually very strange. It's not like you can see it, but it's very
Pixelated, yes, for me too.
yeah, very pixelated.
Oh yeah, then let me just try to actually go into another Wi-Fi.
Or maybe just try the screen share one more time. Maybe just Google Meet being a little funny.
Yeah.
I've never seen that before.
1 second. Yeah, again, German Wi-Fi, I would say. Maybe I would just share the tab. Hopefully it's a bit better.
Yeah, well, actually it is a little better.
Otherwise, I can
I don't know.
just
Is
join
it
the
okay
Wi-Fi.
for the others? Perfect. We're getting thumbs up. Now Christopher's gone. Nice.
So am I back again?
Yes, and the quality is great. Perfect.
All right, great. Then thanks, my local hotspot. And all right, I just wanted to present you a local setup, how you can easily set up your own ELT pipeline instance. Therefore, you could also use our deployed instance on the Airbyte cloud, actually, which is completely fine, and it's completely deployed on Airbyte side. But right now we have some development progress on our side, which is why I just spin up a local instance, which is also very well documented in our docs. So, but I'm very happy to present it to you right here. I just share my entire screen again. Maybe you can give me a quick feedback if you can see anything. Hopefully in a
It's like
satisfying.
super pixelated again.
It's super pixelated again.
Yeah, I don't know why. I don't know what's up with. Maybe turn off your camera or something. Maybe that helps.
Oh yeah, of course I will. Maybe I can also try to share only the tab again.
Maybe I think that seemed to work well.
Yeah, guys, I'm very sorry here. So hopefully you can see it now in a better quality.
No, but actually, yeah, David is right. Like, actually, your camera quality is great. It's just for whatever reason it's great. Now it's fine. Actually, it's getting better now. I can start seeing it. But maybe you need to describe a couple of more things.
Yeah, of course, I will do. All right. Now Airbyte is separated into sources and destinations, and therefore we implemented our own KYVE source, which actually manages the whole data traffic between KYVE, the storage provider like KYVE, and Airbyte itself. And the destination then manages the traffic between the extracted data to load it into your destination of your choice. So it's like a separation of concerns. And Airbyte offers or provides destinations like Postgres, like MySQL, so many SQL databases. And now I just wanted to present you how easy it is to set up your own KYVE source, and therefore you just need to add a new source, and then you just search for KYVE. So right now you have to search for KYVE, and it's in alpha stage. Right now, as I mentioned, I just deployed my own local source. So after selecting it, you can then select your pool ID. For example, I want to use Osmosis with the pool ID 1 and the bundle start ID from 0, which means it just extracts all created bundles. And you can name the source name, for example, Osmosis mainnet. So then you can set it up really quick. So all tests are passed. I hope you can still see my screen. All right, then to create a connection is then a connection between a setup source and a setup destination. I already set up my my deployed MySQL instance to actually load the data from KYVE instantly into my SQL destination. And then you can just select your destination. You could also do it with one source to load it into many destinations, so that would be also possible. And then you can just call the connection name Osmosis mainnet into MySQL. Then you have some possibilities here. Yeah, the question?
No, it was someone joining the call.
Yeah, okay, sorry, missed the sound. All right, then you can select the replication frequency. There you can, for example, select that you want to have an hourly replication frequency, which means that the new created bundles within the last hour are again loaded into your destination. Then you can here set up the sync mode, which means you can have an hourly full refresh of your data in your destination, or you can also have a very handy way of incrementally append this new produced bundles into your data destination, which would be a very handy way of actually getting all Osmosis data, for example, in your destination, or into your data warehouse, for example, like BigQuery is also supported by Airbyte. And yeah, after setting up this, I will just select incremental append, and every hour to have like an hour replication frequency and append all new created bundles. Then you have here a part which means normalization and transformation. This is especially very important for SQL databases, where you can actually have columns of each values of the block raw JSON schema. And there we implemented some schemas to actually provide this normalization. And I can show you an example how the data looks like after the normalization, right after I set up the connection. And then you are good to go. Then you should, you only need to click sync now, and then you are good to go. Then the Airbyte will do everything for you. I'm just want to cancel the sync. That was not my idea, because I already did this a little earlier to actually present you the the database and how it looks after the connection ran through. I hope you can see my pie chart.
No. That is now the compression's kicking. You really can't see anything on your screen.
Okay.
Maybe try reconnecting, maybe to Google Meet actually, because your camera was fine. Maybe just try reconnect to Google Meet.
Yeah. We'll be back in 1 minute.
And in the meantime, we had the question if there's the size difference of the unpacked DB versus the full node data. I think Max might actually have the answer to that.
Yes, this really kind of depends. So like if you do like the plain raw extract and load, then of course your database will be definitely bigger, because you have the entire schema and like not the snappy compression from your normal DB folder. But this is like then, which is still in active development. But like you have the extract and load step, of course you have all the raw data, which will be definitely a little bit bigger, but then you do like the transformation step on it, where you then transform the data to whatever you want, and probably also keep the stuff you want. For example, what we usually do, we also have like our internal indexes and stuff, We don't, for example, keep blocked signatures and all this different kind of stuff, which is like stored usually in the chain. Like we don't keep this, and then of course like this will become smaller. But yes, this is definitely like depends on the settings, I would say. But it can definitely be bigger, and if you prune stuff out of it, it can be smaller.
All right.
Christopher, it works now. There's just one question that just came in, which is very interesting. What is a realistic time delay for having block data available in the relational database source? So on KYVE, right, we always have the delay it takes to upload one bundle. If you set Airbyte to sync on like, I don't know, minute basis, you can add a cron job, or like on a 2-minute basis. You basically have no delay from the KYVE data into your database. You only have the normal KYVE delay of like 1 or 2 minutes. I think it's up to 10 in the worst case, if in case the bundle would almost time out. So yeah, no delay from KYVE into your relational database, but of course the normal KYVE delay is what you have. And Christopher, while I was explaining that, your image is getting better again. It got worse for a second, but now it's fine. So maybe we just rush through the SQL stuff while it's looking good.
Yeah, I don't want to show you that much. I just want to show you maybe to get an idea of how the database could look like after extracting KYVE data into your SQL database. As I mentioned earlier, I'm just using my SQL database for it. And Airbyte has this concept that it loads. I think Max mentioned it some 2 minutes ago where I just left. But Airbyte has this concept that it always creates the raw data, which is loaded into the database. And to actually improve the disk storage requirements, we flattened the data object. And here you can see that the normal structure of a KYVE bundle is always key and value. And in value, there's the validated data bundle, which gets stored on KYVE. So basically, this all gets stored on KYVE, but on the value part, there is everything which is actually validated. And you can see here that we just normalized and flattened it, so everything is on one level. And with this structure, we just managed that we have, after the normalization, have one SQL database where actually everything is stored in. And here we can see like one SQL database. I hope the quality is not that bad. But
it's getting better if you don't move your screen. I think it's like if you just leave it like this, it's actually clearing up.
All right, great. Maybe I can then just switch to the console. All right, just to sum it up, then you have like one SQL database after the normalization and the extraction part from KYVE into my SQL, for example. And then you can do SQL commands, which I'm executing here right now. So I'm just selecting all rows from the pool I just extracted. The pool 1 is, of course, osmosis. And there I just want to get all blocks and all rows where the proposer address is this base 64 decoded osmosis address. You can see here, so there's still a lot of room for improvement, because the better way would be of actually using the osmosis address. This is why we are currently working on an improvement on the whole normalization part to actually make it like more usable and more handy. And this is why we also just wanted to reach out to you, because hopefully we will build a product which gets used by you guys, for example. And therefore, so if you want to have any impact on the development there, and maybe to give some or provide us with some information of how you want to actually use it, or some usage ideas for us, then it would be great to actually get that input to let that influence into our whole development process. So we're still in progress, but we are very optimistic that this will be very handy and very comfortable to use in some weeks, and we will keep you updated there. And when I just run this, then I just get the whole blocks which were proposed by this address. And so I think that's good to go. I think I can stop presenting and stop annoying you with my pixeled screen. And yeah, so very happy to hear some questions regarding it, maybe to hear some thoughts, but yeah.
Yep, there's been one question, which was if the data can be proved within the relational database without having the data stored on chain. So this is not the case. The data that is available in the ELT pipeline is only data that has been stored and validated with KYVE on chain before. So basically, you are sure that all the data you work with inside your database has been validated and is correct. And then the other question was that if the transactions are stored on a base64 encoded protobuf format, and Max looks like he wants to answer that.
Yes, so this is like, you need to keep in mind, this is like the raw data. This was more like, so the current ELT pipeline, like especially the T step, which is like, there's like a lot of stuff to do and like a lot of possibilities what people can do. So right now is for like the extract step, so that like the downloads the bundle, then it verifies the hash so that we've actually provided the correct data and stuff, loads into the database, and then actually the fun begins where you like start. You also have like, for example, the event attributes are base 64. You then decode it to like normal strings again, and then of course you also would have some proto mapping to decode your transactions, everything. And this is where we're like actually right now in development, like finding some good T steps to transform the data to make more use of it. But this, like for Airbyte, is like for the raw data, so that everybody has the full capabilities and the full possibilities to do whatever they want to do.
Perfect. Are there any other questions about the ELT pipeline? Maybe there also, again, next couple of weeks for us, really focusing on getting the transformation step right, putting it in some couple of nicer formats. The good news there is, though, that once we have done this, it is supported for all underlying relational database you guys are using. I don't know. I know the IBS team is using like Postgres. I think most people are familiar with, but yeah, it really supports everything that Airbyte has there. If there are no other questions, I think, Max, is there anything else from our side, or is that mostly it and we can go into the open questions?
Nope, happy for the open questions.
Perfect. Well, are there any open questions? Maybe as the first question.
Would even open up to questions or feedback.
Of course.
Everybody wants to say something. Feel free to.
Or some use cases that we might be able to help also solve that you're having some pain points and so on.
Nice. All right. Well then, thank you, everyone. We will definitely check in with you separately and hopefully do another validator call soon. And hopefully only on the good side of things. Maybe just one thing to add. I know Paul is raising his hands because he texted me that on Slack already. Keep in mind when you guys want to access the data from KYVE, it's free to access. So you can just like sync as much data as you want. Thankfully, KYVE is keeping to that concept. Paul, was there what you want to say?
Yeah, exactly. So all the data you access for KYVE, like that have been uploaded for us, are completely free to access and completely trustless. So you are like safe to use them and can be very good to develop some project on top of it. And just for the one that are in Korea Blockchain Week, tomorrow we have I'm giving a lightning talk at the hackers that we co-host with Celestia, Osmosis, Kepler, and few other projects. But we also have a hackathon going on with Interchain Foundation over the weekend. So if you're in Korea Blockchain Week and want to come in and participate, feel free to just join and text us. And also we're going to be in Token 2049 next week in Singapore. So if some of you are around and want to meet to discuss further about like any question that you may have, feel free to just ping us on Telegram.
Awesome. Well then, good afternoon to all the Europeans and good whatever where everyone else is, and enjoy the rest of your day. Thank you guys. Bye-bye.